Good day once again, dear students. Now, here following from the last example that I gave you, now I would like to show you now how to synthesize this target molecule, right? So we agreed that we needed two Grignard reagents, right? We know if we are going to trace Grignard reagents where your carbon is negative, you see it originally comes from from an alkyl halide, right? That is now where there is what we refer to as the principle of Umpolong, right? For example, where we've got this carbon atom here, right? That is bonded to our halogen atom there, right? And then now the carbon atom is less electronegative than the halogen atom. The halogen atom is more electronegative than what? Than your carbon atom. Therefore, meaning that now the carbon that we have here, it is positive, right? And then now but once you treat it with magnesium, then the polarity it changes, whereby now your carbon atom now, right, becomes negative. There is this principle which we refer to as what? As the reversal of what? Of polarity. Then now this becomes negative, and then the magnesium sits between this carbanion now and our halogen atom, where the magnesium becomes positive, right? So once we do that now, then we treat this with this ester in this case, right? Then we will generate that alcohol. Once we generate the alcohol, once we generate the alcoholic, so here we form what we refer to as an acetoxy, right? An acetylated, with an acetylated group here. Oh man, what am I doing now? Oh, sorry. We generate this, what did I say here? We generate our alcohol, sorry, yes. Then we treat that alcohol with our whatnot, and then we generate this acetylated compound. Sorry. So now how does this reaction actually take place in terms of the mechanism? Remember we said we need two of these, then we treat this with magnesium, we get the reversal of polarity, this carbanion, which is negative, then there is our starting material here now. So from there, this here will come and attack here, then this goes out, then what do we generate here? We generate O12, 1, 2, 1, 2, which is what? Negative, bonded to carbon, that is bonded to OET, 1, 2, 1, 2, right? In that case, yes, and then that side, we've got our hydrogen, this side we have our CH2, and our pH in this case, right? Then, now what then happens here now, and remember now, if I were to close this, you know, and then there is the MgBr positive, that is outside, right? So now, what happens here is that now, this one comes in, and then the OET group or OR group, you see, then it leaves, becomes a good little group in that case. Then now what are we left here with? With a carbon atom that is doubly bonded to oxygen, 1, 2, 1, 2, 1, 2, isn't it? And then now this CH2, and bonded to pH, and then the side bonded to what? To hydrogen, isn't it? Right? That is plus our OH minus, that is gone, right? Now, okay, I can even write it here, plus OET, 1, 2, 1, 2, 1, 2, minus, it is gone. Now, here we've used only one Grignard reagent to reach the stage. Now we bring in the second Grignard reagent, right? What is our Grignard reagent there? It is pH, CH2, MgBr. This is positive, and then this carbon here, it is what? Negative. So what happens here is the negative attacks the electrophilic carbon atom, and then we get again the tetrahedral intermediate that we form here. O, 1, 2, 1, 2, 1, 2, minus, bonded to carbon, CH2, and bonded to pH on the other end. Then this side, we have our H here. This side, we put our CH2 here. Another CH2 that is bonded to pH here, in this case, right? And then if we close here, we close. Then outside, we've got our Mg plus Br, right? Then we treat this with our acid. Then this comes in to pick up the acid. Then what we form here now? We form C bonded to OH, 1, 2, 1, 2, right? Then there is hydrogen there. Then there is hydrogen here. CH2, CH2, then bonded to pH this side. CH2, CH2, bonded to pH this side. Now we've got our alcohol now. Our alcohol that has got two groups that are the same on either side. Then what we do now, we treat this now we treat this with acetic anhydride, AC, that is AC2O. We treat it with acetic anhydride, AC2O, in the presence of pyridine. In the presence of pyridine, then we convert now. It's a functional group interconversion. We convert that OH now to what? To OAC. We convert it to O12 AC. We convert it to what? To OAC. This is bonded to carbon here. Then our CH2 pH that side, and here our CH2 and then here pH this side. Then this gives us our target molecule. You see, this was just to show you now how to, we have designed a synthetic route that takes us to our target molecule. I'm sorry that I didn't have enough what call space here, right? I'll see you in the next class. Organic chemistry is easy. Organic chemistry is beautiful. Organic chemistry is fun, right? You see, I'll see you in the next class. Thank you.